Everyone, 13th tutorial of mathematics 2 is based on complex integration. In this tutorial we discuss Cauchy residue theorem. Theorem says if fz is analytic inside and on a simple closed curve C except at a finite number of singularities, specifically poles z1, z2, z3 and zn inside C, then integration over C fz dz is 2 pi I into summation of r1 r2 up to rn. What is r1 r2 rn? R1 r2 rn are the residues about poles z1 z2 zn. This is Cauchy residue theorem. Now let's discuss one example. Integration over C 2 times z plus 1 whole square upon z square into z square plus 1 dz over the circle mod z equals to 3. If we equate denominator to 0, so we get 0 plus I minus I are the poles which are inside this circle mod z equals to 3. See, this is 0, this is I and this is minus I. All 3 points are inside. Also z equals to plus I and minus I are pole of order 1, that is simple pole. Z equals to 0 is a pole of order 2 because z square is there. So z equals to 0 is a pole of order 2. It is also called double pole. Then let's find out the residues. So first residues about z equals to I. So limit z tends to I, z minus I 2 times that function z plus 1 whole square upon z square. Now we bifurcate this z square plus 1 into linear factor as z plus I and z minus I. So we have this, and when we put z equals to I, we will get minus 2 is the first residue. Now second residue is r2 at z equals to minus I. Again same picture, we will get 2 as the second residue. Now double pole and residue for z equals to 0 z is limit z tends to 0 d by dz of that function z minus whole square into the function, so z square cancel. So we have to differentiate 2 times z plus 1 whole square upon z square plus 1. We apply uv rule, so we get this integration, and then after differentiating this we have to put this limit z equals to 0, so we will get 4. Then by Cauchy residue theorem, since all the 3 poles are inside the circle, so we have to add the residues about these poles, r1 plus r2 plus r3, so it is minus 2 plus 2 plus 4, so it is 4, and 4 2s are 8, so it is 8 pi I. The integration this is equals to 8 pi I. Thank you.